Okay, good morning. Good morning, Julian. Good morning, Jonathan. Thank you for joining me today for the ML cost optimization session.
Good morning. Nice to be here today.
Good morning. Happy to be here.
Great. So let's start. So startups founders that I meet these days tell me that the current economic climate really forces many of them to reevaluate their monthly burn rate and find ways to better control costs. So in today's session, what we would like to discuss is which phases of the ML projects cost the most, mean money, people time, and how to save money and make the most of the budget you already have. But before diving deeper, let's start with a short introduction. I'll start quickly. My name is Mirav Ash. I lead the machine learning business development for startups in EMEA. I've been helping startups with ML research and projects in the past 3 years. And I'm happy to be here and share the experience of working with startups on machine learning. Julian, you can go next.
Yeah, hi, I'm Julian from Berlin, and at Amazon Web Services, I work as a machine learning solutions architect, focusing on startups across Europe, Middle East, and Africa. And it's startups of all sizes and all industries. And I really like to help them finding a technical solution and the right approach using AWS for their model building, experimentation, training, and deploying of the machine learning models. Over to you, Jonathan.
Hi, I'm Jonathan, the CEO and co-founder of Deci. Deci is a deep learning development platform focusing on building, optimizing, and deploying deep learning solutions while focusing on the inference performance, which also highly correlated with the cost associated with running production workloads of deep learning.
Perfect. So again, thank you for joining. You two get to meet a lot of data scientists in your daily work. What do you hear from them about cost when it comes to ML?
Yeah, that's true. In my role, I have the pleasure not only to work with data scientists, but also with CTOs, machine learning engineers, or the heads of data from machine learning startups. And especially in this more earlier machine learning startups, typically the ones that are maybe pre-product launch or in the early phases where they still invest a lot of energy into building their POCs, getting their models right, we can see that in this phase, a lot of the cost comes from training, especially if large compute clusters or GPU instances are involved. So typically from these kind of startups, we hear questions about how can we optimize our training costs while not limiting our data scientists in their productivity or in the experiments that they can run. What do you think, Jonathan?
So you're right. Early on, people focus on building the model, and then they get to a mature product that they start to run inference workloads. And then at some point, they see the inflection point where inference workload grow and grow, and then the cost is starting to accumulate around inference workloads. They're running multiple models in the cloud, and they start to think about optimizations and how they can reduce that cloud cost, which comes later after having a product that's starting to see some scale. So those are the two aspects. One is the training, the second one is the inference. And we are seeing a company, a relatively early stage startup, which has a product that is running with 24/7 clusters of about 10 to 20 GPU instances running all the time. And the cost of this workload is very significant for that size of startup, and they're starting to think about how to reduce those costs, and this is what we're going to talk about today.
I agree. And before going deeper, you mentioned potential cost saving when it comes to training and inference, and we're going to touch that in details. But you also mentioned data scientists, ML engineers, maybe DevOps team. I would like to ask you, when it comes to machine learning, who's responsible for cost optimization?
Yeah, it's a good question. I think especially in early startups or small startups, we see this pattern that everyone wears multiple hats and everyone has to fulfill multiple functions. So it's not uncommon that in these early days, the first data scientist is also the machine learning engineer and responsible for the infrastructure, or that even the CTO is still directly involved in such tasks. So there it's clear. But even as startups grow, I think cost optimization can best tackled as a team effort, and every role can contribute. So for example, as a data scientist, it's in your hand to make efficient training code and smart experimentation design. As ML or DevOps engineer, you can really think about the architecture and the right choice of infrastructure to make it cost efficient, and so on and so on.
Yeah, it's a really team effort, as you mentioned. So let's start with training. Julian, based on your experience, what are the top 3 factors driving training costs?
Yeah, so for machine learning training, really the biggest cost driver that we see in startups is often the cost of compute or instance costs. And of course, there's secondary costs like costs of storage for data sets, or the costs that go into data preprocessing and data cleaning. But usually the compute costs are an order of magnitude larger. So let's focus on compute costs today. Compute costs, I think, make sense. We can break these down into 2 aspects where cost optimization can happen: time, training setup, and instance type. So let's dive quickly into each of these 3 pillars. So for number 1, for time, I really mean reducing the time that instances are running, especially if they're not utilized. That's a huge cost optimization opportunity. So to make it more concrete, let's look at this picture. On the top row, we see a setup, how I often see it in early startups or startups that migrate from on-premise workstations into the cloud. And they just manually set up, for example, a GPU instance or a GPU-powered Jupyter notebook. And then a data scientist connects to it to develop and build the model and the whole experiment setup, and then manually starts the training. And when the training finishes, the instance keeps running until the next time a data scientist sets up a new experiment. As you can see, there's a lot of idle time where the GPU instance is running, but no experiments are happening. So as a first step in the middle row, I would always recommend to start with some automation on the shutdown functionality. So for example, if you're using a Jupyter notebook or an Amazon SageMaker Studio notebook, you can use a lifecycle configuration to automatically shut down idle resources after they're done. As we can see, now we've already massively reduced the time the GPU instance is running. But we can go even one step further. An even better approach that I see startups adopting is switching the building and the development from a powerful instance to a more affordable, smaller instance, or even running it on local machines. So for example, running your Jupyter notebook on a CPU instance for development or on your local machine, and then using a managed API to create your training as a job on managed infrastructure using technologies like AWS Batch or Amazon SageMaker training jobs, where the service handles for you creating the infrastructure, starting the training job, and terminating the infrastructure once the job has finished or if an error occurs. And as we can see with such a setup, we really reduce the time and instances running to the actual training time and get the most cost optimal setup. As a nice plus, with this approach, is also much more streamlined to run many jobs in parallel from the same development environment. So that was about instance training time. Let's come back to the middle pillar. As I said, the middle pillar is all about the training setup itself. And by that I mean all the things that are in the hand when we decide how to create the training. So what we see sometimes with early startups, that they have quite a bit of suboptimal setups here. So recommendations that I give them is start small, use a small data set to first make a proof of concept, create a baseline, and use things like early stopping to not train longer than needed. Also, there's a lot of other techniques in this bucket. For example, using transfer learning, where you use an already pre-trained model, for example, from the Hugging Face hub, and just fine-tune it on your data set instead of training from scratch. Other aspects in here are, for example, making hyperparameter optimization not unnecessarily exhaustive. And there's a couple of tricks that I'm going to link to in the descriptions. For example, on Amazon SageMaker, you can use warm starts or reusing of the instances in your hyperparameter jobs, or use tricks like Bayesian optimization to reduce the number of hyperparameter jobs that are running. A last one in the training setup category that I think is a really nice low-hanging fruit is making sure you use an optimized and up-to-date machine learning framework. So for example, in this example, just the difference between using the vanilla TensorFlow version and using the one that you can get when you use the Amazon machine learning images and container that is optimized for the AWS infrastructure, you can get a 7.4 improvement of performance just by switching the machine learning framework without needing to make any code changes in your training setup. So that was all about the training setup. Let's come back to number 3, which I said is the instance types or the purchase options. What do I mean by purchase options? I mean, instead of using your instances on demand right when you need it, you can use spot training. And for spot training, you really use EC2 access capacity that is available. The problem here is the spot instances can be reclaimed at any time. So you should only use this for workloads that can be interrupted and start from checkpoints again. And for training workloads that are not time critical, as it can take a little bit longer for the training job to finish if spot interruptions occur. But spot interruptions are a great way to run the same training job on a much cheaper purchasing option. The next one that falls into this category is really using the right instance. So instance and hardware right sizing for your problem. This means if really making sure that you use the smallest GPU and the smallest instance that is needed for your training job, or using hardware that is optimized for your job. So for example, AWS recently launched Intel Habana Gaudi instance that have a specialized training chip that can provide 40% better price performance. And I'm really excited to see soon in the next weeks coming into general availability, AWS's own training chip, the first chip from AWS specifically built for training that's going to see probably amazing price performance.
Super interesting. So it seems like, we can try to control time, training setup, instance start. What are the potential saving costs that we can expect by performing some or all of these?
Yeah, that's a great question. So for the time pillar, the numbers that I typically see in startups is if they go from manually created instance to managed training jobs, an improvement of 20 to even 60%, because often these instances were running not very well utilized. In the training setup bucket, it's really hard to put a number on that because there were so many different techniques that I mentioned. But as we said, this low-hanging fruit of just switching to your machine learning optimized framework was an easy win with a 7.4% performance improvement. On the instance type and purchase options for spot training, you can get up to 90% cheaper costs over on demand. So that's a big gain. For right sizing your instance, I would say something in the order of 30% is what I typically see. And for these new hardware types, they like the AWS Trainium or the Intel Habana Gaudi training chip, we are in the order of magnitude of 40% better price performance over traditional GPU instances. So let me try to just make this a little bit clear with an example customer that I recently had. So I recently got the chance to speak to the head of ML of an exciting young startup that uses machine learning for drug and compound discovery. So they are crunching huge amounts of this data on Spark and on Amazon EMR, and then they're training a transformer model from scratch on this data. And they were using a powerful GPU instance on running Jupyter Notebook on it to run their training workload. This allowed them to get started very quickly, but created a lot of unnecessary costs as this instance was running around the clock. So we decided to take an immediate step and enabling auto shutdown via lifecycle configuration on a Jupyter Notebook instance, and created a plan for the midterm to switch from a manually managed created instance to having Amazon SageMaker managed training jobs or using AWS Batch.
Super interesting. Thanks for sharing the last example. Seems like there's a lot of options for cost saving when it comes to training. Some of them are really choosing the optimized hardware or even just choosing to run on spot instances and much more. I want to move to inference and ask you, Jonathan, if you could share which are the top 3 cost driver when it comes to inference.
So when it comes to inference performance or cost optimization, we see multiple layers that we can touch, that each one of them is independent on the other, and they are all together contribute to the overall performance or the overall cost of the inference workload. We'll start from a cluster level optimization where we set the setting of how we do auto scaling, how we work with the largest batches possible, either doing automatic batching or setting the batch in advance, and also considering options of running serverless inference instead of running standard VMs. So all those settings on the cluster level can reduce the amount of machines or the amount of compute resources that we are running at a time. The next level, the next layer that we're considering is the instance and runtime level optimization. Here we consider, for example, what is the type of instance that we are selecting, what is the type of underlying hardware where we can run GPUs, CPUs, or other inference hardware that is available in the cloud, like the AWS hardware, and also considering what is the runtime optimization that we are using and how we leverage methods like graph compilation and quantization in order to get better performance for the model running on the given hardware. The quantization technique also reduces the model size that is running and can enable us to use multiple models on the same GPU, for example, and use multi-model runtime inference workloads where we use one GPU for running 2, 3, or 4 models in parallel and share the resources, the compute resources of the GPU over those models and running all of them on the same node, reducing the amount of hardware that we need to provision in order to enable that workload to run. The last layer is the model level optimization, where we want to improve the runtime performance or the memory footprint of the model in order to be able to get more queries per second or get more throughput from the available hardware that we provision. For that, we can use distillation in order to use smaller model with the same accuracy. We can do model pruning, especially channel pruning. We can use DASI as a solution to model optimization, improving the performance, the runtime performance, and the model size of the model by automatically designing better neural architectures. And all of these can enable us to run for the same hardware, more inference queries per second, improve the throughput of the machine, and improve the cost associated with inference. So when we combine all those 3 layers, starting from the cluster, running through the instance and the runtime, and ending up with the model level optimization, we come to an end-to-end optimization that can improve significantly the cost and the performance of our inference workload.
That's nice, and it seems like DASI has a lot of experience helping customers, in inference efficiency. So, based on your experience, what is the expected cost saving if you're going to focus on inference efficiency?
One thing that we need to remember that each one of those layers are independent by the other at some sense. So every saving that we can bring in one layer is multiplied by the saving that we can bring in another layer. If we'll start from the cluster level optimization, it's mostly a trade-off between the availability of compute to run inference in low latency and the over provisioning or idle time of the compute that we provision and spending cost on that. And by setting better settings for the auto scaling, for example, and running in batches, we can get an improvement of about 2x in the cost of this cluster without losing anything in terms of latency or availability of compute for running inference. On the instance runtime, we can get 2 to 4x based on the techniques and the methods that we leverage, from graph compilation to model quantization, and also selecting the right hardware that will be best utilized by the model type that we're using. And on the model level optimization, we see something between 2 to 4x by improving the model, selecting or designing better neural architecture for that model at inference time. So if we multiply all of this together, we can get more than 10x of inference performance improvement, with sums up to more than 90% reduction in cost. But obviously, we can't do everything at day one, and we need to decide where to start from. And this is something that we'll later discuss.
Sure. I want to ask you, Julian, for another example. In our last call, you mentioned some great customer examples that really illustrate cost saving at inference. If you can share one of them.
Yeah, I would be happy to. So this is an example that I'm also going to link the full story for in the description below. That is a customer called InfoJobs, and 2 of my colleagues work with them. InfoJobs they build a platform to make the perfect match between candidates and employers. And they're using natural language processing for things like automatically processing an applicant's CV. So they had a problem that they wanted to reduce inference costs, but at the same time, they didn't want to sacrifice on performance, especially latency. So they sat down with the team from AWS, with the machine learning specialists, and tried a variety of approaches. And as you can see in the chart below, from starting on CPU instances with unoptimized code, over going to optimizing this, going to GPU instances, going to GPU optimization, going all the way to the Inf1 instance, which is AWS custom inferential chip, and compiling for this target hardware, they were able to not only achieve 75% lower inference costs, but at the same time reducing the prediction latency. So really getting the best both of like more or less GPU power and CPU cost structure. I think that's quite an astonishing result.
Yeah, really impressive. So we covered the top 3 cost drivers in training as well as inference. And you said there's some low-hanging fruits, but in some cases, you really need to decide where to start. And so I want to ask you, what is your tips and maybe others that you didn't mention when it comes to cost savings?
Yeah, as we already quickly mentioned, it's always important to focus on the low-hanging fruits, especially as a startup if you're short on time. So we mentioned things like switching to the right machine learning framework, to the latest version, an optimized version, enabling auto shutdown. These things are really quick to do. So start with stuff like that, and then prioritize the midterm cost savings based on where you really see your spending. We focused this session today really on the core driver for compute and instance costs. But of course, there can also be other cost optimizations in the machine learning space. If you see that, for example, data storage is exploding. So we will link in the description below to a blog that nicely compares various storage options and should make it easier for you to choose the right one, for example, between S3, EFS, or Lustre FSX. Yeah, over to you, Jonathan.
So yes, I think that the first thing to assess is to understand where the money goes in terms of what are the layers that we need to optimize. Either it's the model level optimization or the runtime level optimization, and where to start from. Because we can't start doing everything at a startup and choosing one layer to start and see how it impacts the overall cost. And I think that one of the questions is to check is what is the average utilization of the hardware that we are using. If the utilization is relatively low, then we can think how we can provision more efficiently and improve the utilization of the hardware that we are already paying for. But if we're in high utilization for the hardware, then we need to think about other techniques in improving what we can get from that hardware that we use to get better throughput or better utilization of that in terms of queries per seconds of deep learning inference workloads. So those will be the guidance for startups to see whether utilization is high or low and select which are the layers to start to optimize from.
So it seems like that's the first thing is really to identify where to invest time and where to start optimizing cost. And I'm guessing if you have a better estimation of your cloud resources usage, you might want to consider ML compute saving plans. So these saving plans, you can then commit to up to 3 years, so 12 to 36 years. 12 to 36 months. And these ML compute saving plans will help you reduce cost by 64%, up to 64%, which is a huge cost saving. But again, it's all on top of first decide where to start, then choose the options to optimize, then of course saving plans as another layer that you can utilize and to save cost. I want to thank you all. It was super interesting hearing your experience working with customers, working with startups on cost saving and optimizing saving and performance. So thank you, Jonathan. Thank you, Julian. It was a pleasure hosting you on this ML cost optimization session.
Thanks a lot for having us.
Thank you very much.
And thank you all for listening. Please see the links below. We are sharing more technical content in the video description. So a lot of pointers to more technical content that will help you, make a better decisions about storage, about compute, the right hardware, and things like that. Also some benchmark use cases. And keep an eye out for an upcoming Ask Me Anything session that we will host, where you can ask us questions, and we will do our best to help you with a specific and concrete answers to your challenges when it comes to machine learning cost saving. Thank you all. Bye-bye.